This lesson is on section 5.3, concurrent lines, medians, and altitudes. We're going to start by talking about what concurrent lines are. They are lines that when you draw them, they all intersect in one point. That point is called the point of concurrency. We are going to concentrate on drawing 4 different kinds of concurrent lines in this section. The first one we are going to talk about is perpendicular bisectors. A perpendicular bisector is a line that you draw that goes through the midpoint of a line, and it also goes perpendicular to that line. I'm going to use a triangle to represent the idea of drawing the 3 perpendicular bisectors, one on each side, and they will all intersect in one point. That's what makes them concurrent lines. If I draw the perpendicular bisectors for each one of these, it has to go perpendicular through the midpoint. So I go here, find the midpoint, draw a line perpendicular, come over here, find the midpoint, and draw the line perpendicular. Notice that they all meet in one point. That point of concurrency for perpendicular bisectors is called the circumcenter. The circumcenter is significant because it is exactly the same distance to each of the 3 corners of the triangle. The significance of that is it allows you to do something called circumscribing a circle. It allows you to find the radius of the circle that if you went from the circumcenter out to the edge of the vertex, you could draw a perfect circle that would simply touch all 3 vertices of the triangle at the same time. This concept gets used in architecture and archaeology. The next point of concurrency we are going to find involves angle bisectors. Angle bisector is a line that cuts an angle into 2 equal parts. If I draw the angle bisectors in this triangle, I will draw a line that bisects this angle. I would draw a line that bisects this angle. And I would draw a line that bisects this angle. Notice once again, they all intersect at one point, making them concurrent lines. The angle bisector's point of concurrency is called the incenter. The incenter allows you to inscribe a circle. Circumscribing goes around the outside, inscribing goes around the inside. So the incenter, it is equal distance from all 3 sides of the triangle, so it allows you to draw a circle on the inside that simply touches all 3 sides of the triangle in exactly one spot. The next one we are going to talk about is the median. The median is a line that you draw from the vertex, but it goes through the midpoint of the opposite side. Median goes through the midpoint. Again, they will all intersect in one point. That point of concurrency for the median is called the centroid. The significance of this point of concurrency is that this is the center of gravity for your triangle. What you should be able to do is if you were to cut out this triangle after you find the centroid, you should be able to balance the triangle on the end of your pencil. Centroids are used in all kinds of mechanics and designs to find balancing points. If I draw in these medians, I will draw a line that starts up at the corners and it goes through the midpoint of the opposite side. So the median for this side would look basically like that. The one for this side, for this angle, would look basically like that. And the one for this side would go through this angle, hitting the midpoint of the opposite side. There is my centroid. So if I were to cut out this triangle, I would balance my pencil right on the end of that point. The last one we are going to talk about is the altitude. The altitude actually shows the height of the triangle at different points. You draw the altitude by drawing a line from the vertex, but it has to go perpendicular to the opposite side. The point of concurrency for an altitude is called the orthocenter. I couldn't find any significant uses for the orthocenter, but since I was showing you the other three, I decided to show you this one as well. What's interesting about the altitude is that it looks very different depending on what kind of triangle you used. With medians and angle bisectors and perpendicular bisectors, it doesn't matter what kind of triangle you use, they all basically look the same. But with altitudes, your point of concurrency and the way they look can be very different based on what kind of triangle you use. This triangle, an acute triangle, if I draw the altitudes, they go from a corner, perpendicular, they have to make a right angle with the side that goes across from it. Starts at a corner, drops down so that it's at a right angle. Same thing here. Starts at a corner, drops down so that it's perpendicular. This point right here would be the orthocenter. Now, in an acute triangle, it looks pretty much like the others. In right triangles and obtuse triangles, altitudes look a slight bit different. If I draw a line from this vertex perpendicular to the opposite side, that actually follows along the side of the triangle in a right triangle. Same thing with this one. If I start at this vertex and draw perpendicular to its opposite side, that ends up being an actual side of the triangle. And the significance of that is because this is already a right angle. When I draw in the third piece, though, that's where I will see where my point of concurrency is. It has to go through the vertex perpendicular to the opposite side. Notice that in the case of a right triangle, your orthocenter is actually already on the triangle, as opposed to an acute triangle where it was inside like the others. In an obtuse triangle, the altitudes even look a little bit more different. Okay, I go from a vertex perpendicular to the opposite side. But if I go from this vertex perpendicular to the opposite side, I can't do that and draw the line inside the triangle. In order for it to be perpendicular, I would have to extend this side out. I would have to extend this side out and draw it on the outside of the triangle. Same thing here. If I go from this vertex and straight down so that it's perpendicular to the opposite side, it ends up being on the outside of the triangle. Then when I draw the third altitude in from the vertex and it goes perpendicular to the opposite side, you can see that out here would be my point of concurrency. This would be my orthocenter. My orthocenter in an obtuse triangle actually sits outside of the triangle. So altitudes and orthocenters are a little bit different than the other three. This concludes this lesson. Your homework is on the next page. And for regular geometry and CT geometry, it is 5.3. For honors, it is enrichment worksheet 5.2 and 5.3.